welcome to this session of the Florida PowerShell user group. I'm Maximo Trinidad, and I'll be talking about PowerShell, SQL Server, SMO simplicity. This is also a series that I've been running on my website, and I've been posting a lot of SMO SQL Server code, and that makes your SQL Server automation easier to spread. So let's get going here. First of all, thank you to our sponsors, Office 365, Sapiens, O'Reilly, Inclusive, Foresight, and also we have a new sponsor who joined in, which is DeBard. They have another version of SQL Server Management editor that you can manage and work with SQL Server. It was pretty good too. I will demo that sometime along this year to see the benefit of using something else different than SQL Server Management Studio. Contact information, this is a routine, so I'll post them in there for everyone who want to contact me and ask questions. Feel free to do so. My email, Twitter, and my blog site. All right, now we'll go straight to the demo. All right, so we're talking about SQL Server SMO simplicity with PowerShell, and what I want to relay is this is straight SMO. It's not, you're not using SQL PS module of SQL Server, and by using this few line of code to initiate a connection to SQL Server, then it's all you need to start working and understanding the objects you're building after you have established that connection. And at the same time, I'm going to show you a couple other objects within the connection before you start working with SQL Server that need to be in place that will benefit, that you will benefit from when running long-running queries. Meaning queries that are longer than 10 minutes will crash if you don't use these additional parameters. Okay, and that's the way SMO by default acts. Changing these following lines within the connection help you extend the statement running on that server, executing on that server. Okay. Let me just start my demo here, and I'm using an old start demo script, which runs the content of my script file, having all this line of code I'm going to demo. So let's go ahead and go to the console. Okay, I'm going to start. And by the way, I'm running PowerShell version 5 April preview edition. So a lot have changed from version 4. Okay, first line is the system reflection assembly, load with partial name, where you include the assembly name to connect to the SQL Server, which is the Microsoft SQL Server.smo. I'm piping it to another command named outNull, and this is for, so I don't want to see the result set of that when you're loading that assembly. So it will ignore the output that it generates. So now, a good example is that you can use a class named Microsoft SQL Server Management SMO application with the method enumerate available SQL Server to scan what SQL Server are discoverable on your network. For most part, SQL Server administrator will tend to by default not to have their servers discoverable while they're out there on the network. This is a good way to find out which server still have those settings discoverable. so you can, just turn them off. And what you do is just run this class with a method, and you build a file, you build the object. In this case, I'm calling it SQL Server all, and in order to display the name of the server, so I could, later on go there and make sure that I make them not discoverable. Accessible for the network, but not discoverable when you query on the network. As you can see, I have two of them because I'm using my local computer, and we're going to be working with the SQL Server 2014 database. All right, so my next block of code, here's when I establish the connection. First, I build my object with the SQL Server instance name. In this case, is Trinidad MSSQL 2K14, and then I started the connection using building a new object called the SMO, Management SQL Server, with the instance name. That builds and gathers all the information, all the .NET collection objects into my PowerShell variable, so I can explore more their contents. In this case, it's called SQL Server object. And the next two line of that I'm including in here after the object is created is what set some timeouts. Okay, you got the connection timeout property that can be set, and a statement timeout that can be set. The important one is the statement timeout. The statement timeout by default on SMO, when you run regular queries, I discover is limited to almost 10 minutes. After that, it drops. That statement that's running, it will terminate with an error, with a timeout error. You have to set this statement timeout equal to 0. Now, I provided the sample for the connection timeout in case you need to leave the connection on for an X number. In this case, is seconds, if I'm not mistaken. So I put 21,600, which will be the equivalent of 6 hours. That's my estimate. But it's an example, so you don't need to run it, but you need to know that it exists in case that you need it. So the important statement is the important line. The property here is the statement timeout equal to 0. It means do not. The timeout is forever. It's not gonna terminate. It's 0. Okay. Now the following line of code that I'm showing right now, although is commented out, I'm gonna highlight here the ones that you need to pay attention to. Is in case you need to use a SQL Server authentication instead of a Windows authentication. Initially, when you establish a connection using SMO, by default, it goes to Windows authentication. If you want to proceed working with your objects with a SQL Server authentication, then you need to use these following sample lines. In this sample line, you will notice that on the password variable, I'm using single quote. In case you're able to use $sign or special characters, you use single quote in order to those special characters to be ignored. That's the difference between double quote and single quote. If you use the $sign character in a double quote, PowerShell will think, okay, I'm looking at a PowerShell variable, and it will take it that way. So you need to ignore the $sign, you use single quote. But this is the block of code that will help you convert, change your Windows authentication to SQL Server authentication. Okay? Alright, so now, an example is now how my object build is connected, how my object build, and I want to go and look at a particular property called information, because this is a .NET object. One of the properties within the object is called information. And this is just to make it easy for you to see how much data is in there. And as you can see, I do the information property, and it brings all this information about my SQL Server I'm connected to. much information is in here. This is just one little sample, one single property. Now, how do I find out all the properties of my PowerShell objects? Very simple. What you do is use the getMember commandlet to pull that information out of that object. And this is how you do the discovery. This is how you explore your PowerShell object. Now, if you need to, when you use the getMember, it's very valuable when you tied in that getMember with another commandlet called outReview. In this case, you're going to do a piping. It's called piping. All those little bar between commandlets is called a pipe. So you're going to move the information from one object to another, and then it gets processed. In this case, I'm moving all my .NET object information to the getMember. The getMember is giving me all those collection of objects that are in there, and the outReview, you're going to display it in a pop-up window, so we can make it easier for me to look at and build the script. And in this case, I have one sample that will show only all the properties, and I got another sample that shows the methods and properties. And of course, that's the way you can, if you want to isolate, I'm only interested in looking at properties, then you can do the outReview only for properties, outReview only for methods, or just display it all. Okay, so that's a very useful tool. It is a very useful command. The outReview, use it everywhere you want to display some information before sending it to a file or even to a screen. So next, what I'm going to do is another example how I use the grid view with the parameters name pass-through, and also include a title for it, because in this case, I'm going to grab this tool liner of code, building an object with all the database name to it, but it's not all the databases that I want. I can pick particular databases. So the grid view is going to bring me a pop-up window with only the name of the databases from the SQL Server, and with the title telling me this is SQL from this server, the SQL Server name is this, and select the database. And I can click holding the control key down, and I can click individual databases, 1 or 2 or 3, and that it will grab me the result set and save it in a PowerShell result variable. In this case, I'm calling it selected databases, excuse me, and that we can work with it, right? So I'm going to do that. This way it comes up. I have in my local database, I have Adventure Wars 2014, and I also have, let me hold on the control key, I have a Max test database. So I click OK, and that result set is saved in my variable. And the next step I'm going to do now is I'm going to go through each of those databases, and I'm going to build a query containing this data space used, space available of the database, what percentage free space is left on the database, and have a series of fields in there: owner, create date, recovery model, some information that you might be interested in looking at. And in this case, well, I have different options, how to save that result, right? First, I can display it on screen. Then I'm just grab the result, my object result, display it on screen. We're just going to see that, okay, maybe my screen is limited, so I can't see the whole columns that I selected, that I just created. The next thing will be, again, our grid view. We got a grid view. There's no limit of you can resize the pop-up window which way you want. Right, and there it is. You can see it. Our grid view is there. this case, I want to save it as a CSV file because I have Excel loaded on my machine. And for most part, when you open a CSV file, the application that will want to open it with is going to open in Excel. The quickest way to build an Excel file. And there it is. You know, open Excel. It built the CSV file, and I query to open it. You know, I put the command invoke item commandlet to go ahead and open the file for me. It will open in Excel. Just a quick and dirty way to create an Excel file, but it's in a CSV format. Then you can save it, format it, and do whatever you want to the file. Okay. One thing to notice is that I'm giving a lot of little special techniques used when building file names. I'm using also special formatting to include in the file name date time stamp that is valid, that will be saved. And at the same time, you know, you can reuse that in this case called a report name. You put a report name in order to save, to export to that report name, and or then to also invoke that report name back to your through PowerShell and open the Excel file. So the next now, we jumping from databases, we're going to tables now. So in this case now, well, I'm selected the AdventureWorks 2014 database, and I want to grab my database object out of my SQL Server object and put it on a variable. In this, I just want to make sure that I got all the names that I wanted, that it's displaying what I want, you know, that my object is correct. Here it is. I got all of my tables in the AdventureWorks 2014. Now I'm going to proceed and use a special block here, color block, that there's a lot of formatting on the existing properties. And for this, I'm using script blocks. The script blocks allow me to manipulate that property value. And as you can see here, the property, the script block basically is within the add parentheses, open bracket, and closing bracket, and you have a couple areas. Label or name can be used in here. Equal the name you want to change the property name of, and the expression is where you use your property, your object property, and you want to do an expression against it. It could be a block of code, which you'll see here eventually, and so it's very powerful. It's like in SQL Server, this is a cursor in SQL Server. For each line of data that is going through, you can run something against it, one line at a time. And a good example of that is, you can take a look here at last table date, last table update information. On the expression, I'm running a T-SQL query. I'm running a query string that is going to be executed against SQL Server to bring me the result for that table back to this line. And this is very powerful stuff. Very powerful stuff. And it works. So now I build my result set, including my embedded SQL statement in there. And as you can see here, got the column build last table update. It doesn't show anything there because there really hasn't been any update done to that database. But I've used this in production already to discover what tables has been updated in the evenings. So this code works. All right. So now a very important piece is what happened. You build objects, and sometimes you want to keep those value of that object or in other words, you don't want to lose them, right? Because if you run the query again, whatever, it changes the value, right? Well, there's a technique you could use to save the PowerShell object as an XML. You can output that object as an XML, and this is very powerful, okay? And just because by doing this, you can go ahead and take it home, keep working with the object until you want to create the query you want. You want to build the result set that you want. But you have one, you had an XML, you go back and import that XML back as a PowerShell object, and then you can go ahead and keep working with it and reuse it because it's already saved. It's already saved as a file. Okay, this is a very nice technique to know that you could use for working in projects, that the data just changes, so you don't have to wait until the evening for data to show up again or something, you know. So just this is open your mind to possibilities. Okay, so I'm doing the export. Then the export, what it's going to do is it's going to create the file, and that way you can go ahead and import back. You can open the XML file, see the contents, then you can import back the file and keep working with it. And we have a little error here. Let me see what it is. It says XML. Oh, there it is. Okay, we got it here. And we move the screen here. This is an example of how the XML looks for a PowerShell object. Some more information in here. Wow. Okay, here it is. All right. So to give you an example, what it looks like, you have all the properties or its values. I mean, and then you keep working with it. So this is a very big XML file, very big XML file out of that object. And then I can go back, grab that object back, and I'm going to create a PowerShell object called import results object, which is going to import back. And I'm going to display it in a grid view just to show that you can get some information out of there. There you go. See? Awesome. All right. So now, working with databases and tables, sometimes it's good to know where your database and transaction logs are stored at. I mean, in a locally in a computer, in a laptop or desktop, is meaningless, right? But think if you're connected to a network or a SQL Server infrastructure, then of course this is more valuable. So here I'm just showing a couple samples of how you can query, get information from either a particular database and or all the databases in your SQL Server engine. It will display the file location of those databases. That's what I'm showing right now. Okay. Then again, I'm using, when I do the select object, which is the way you query your PowerShell objects, I'm still using the regular properties as they are in the objects, and for those I want to change or do some calculation against, then I'll use the script block, which shows label, expression, and the block of the code against that property. Now I'm going to show, okay, now I show one individual database, and I want to show this be all of the databases that are there. I'll give you an example here in an outgrid view, which this case will show you the size in gigabyte, the regular size, that way you know how it's stored normally, and then the calculated size, and then you see also all the file names of those databases. The same you can do for the log file, which is very important sometimes, because, I mean, trust me, sometimes you have a policy of log file should be on this drive, and sometimes they're not. Sometimes they keep building databases, and the log files are scattered all over their server local drive or somewhere else. So this is a good way to find those who are in the wrong place. It's a very, very good script to use. And now sometimes you need to, in the case that you need to move some databases and or log transaction files around, you need to know how to build your UNC paths in order to perform those moves and or mappings, right? So there's a little technique here showing how to create those UNC paths. You can see both the path for the data and the path for the log file. In this case, of course, it's local drive, so I have both, but the data is, the log file is also. If you want a network, the log file are somewhere else. All right, so this ends part one of the SMO.